If you placed 2.71 moles of nitrogen gas in a 2.38 liter bag at 25.6 degrees Celsius, what would be the pressure of the gas? In this problem, I see one value for the number of moles, a single value for the volume, a single value for the temperature. Now there's no chemical reaction, but since there's only one set of conditions that we're dealing with, we must use the ideal gas law. PV equals nRT. We can go through and start looking at what numbers we can plug in. If we look for the pressure, well, the pressure is what we're actually trying to find as part of this problem. So I'm going to leave that just as P. For volume, I have 2.38 liters, and since volume needs to be in liters, I can plug that in just as it is. N needs to be in moles, and we have 2.71 moles of the nitrogen gas. R is always the same value of 0.0821 liters atmospheres per mole Kelvin. And our temperature is 25.6 degrees Celsius. But we need to convert that before we plug it in to our formula. The temperature in the ideal gas law needs to be in units of Kelvin because, again, Kelvin can never go negative, and pressure, volume, and moles cannot go negative either. We have to have a temperature that follows suit. So if we look at converting the 25.6 degrees Celsius to Kelvin, Kelvin equals degrees Celsius plus 273. 25.6 degrees Celsius plus 273 gives me 298.6 Kelvin. Again, the 273 is treated like a conversion factor. And thus ignored for significant figures. So, if we have 1 decimal place in our original measurement, we need to make sure that we have 1 decimal place in our converted measurement as well. If this were multiplication and division, it would be total sig figs no matter where they were, but addition and subtraction goes off decimal places. So I have 298.6 Kelvin as my temperature. Now I can solve for pressure. Pressure would be the 2.71 times the 0.0821 times 298.6 all over the 2.38. If I'm multiplying by the volume on this side, when I bring it to the other side of the equation, the other side of the equal sign, I'm going to do the opposite math operation. So if I'm multiplying on one side, I'll divide when I move it. Now, we can go through and do some calculations. 2.71 times 0.0821 times 298.6 divided by 2.38 gives me a pressure of 27.9 atmospheres. Since the 2.71 has 3 sig figs, the 2.38 has 3 sig figs, and the 298.6 has 4 sig figs, the ones with the fewest win. So our answer can only have 3 sig figs at in the end. The gas constant is also treated as a conversion factor and ignored in terms of significant figures.